Okay, this is the third video in a series of videos on the magnetic field of a long straight wire. As you can see, I have my data in the IO Lab software, and I actually want to create a spreadsheet for the data in Logger Pro or in Excel, because I will actually be able to do analysis, curve fitting, and all that other good stuff in those programs. So here's what I'm going to do. I've taken data runs for 1 centimeter, 3 centimeters, and 5 centimeters. What I'm now going to do is I'm going to enter the 5 centimeter into Logger Pro, but I need a few columns. So let me bring my Logger Pro over, and here is the setup for my spreadsheet. I have the distance in centimeters, that's Z. I have also Z in meters and 1 over Z in meters, and I'm going to use that later on in the broadcast, or actually later on in a demonstration, to show you that you're going to use that to determine the current out of your in your wire. So I have my values for the magnetic field of the Earth, BXE, BYE, BZE, and I've done measurements for 1 meter, 1 centimeter, and 3 centimeters, and I want to put the 5 centimeter in. But I need a calculated column. I need a calculated column for the distance in meters, and the calculated column for 1 over the distance in meters. And then I need calculated columns for the wire, BX, BY, and BZ, and the magnitude of the field. So here's what you do. If you want to create a calculated column in Logger Pro, I click on Data, and I create a new calculated column. And in this calculated column, let's say, for example, I want to calculate the magnetic field of the wire. I want to subtract off the magnetic field of the Earth from the magnetic field of the measurement. So I'm going to call that BX W. So that's the X component of the magnetic field due to the wire from by subtracting off the Earth's field. So now I'll create a short name, BXW. I don't want to change that. The units you can put in Greek and all that other good stuff by clicking on this drop down. So Greek lower, I want to use microteslas. And now down here, which is the most important part, is the field. So I want to subtract the magnetic field of the Earth from the measured magnetic field. Now I have to do this for each component. So Logger Pro is very easy to do this. I'm going to click on the variable columns, and I want to subtract, I want to use BXM, that's the measured value of the magnetic field, and then I want to subtract off the magnetic field of the Earth. So I'll use that, and you have to do that for each component, BX, BY, and BZ, in order to get the true values of the magnetic field. So once I have my formula to my satisfaction, I click Done, and then the Logger Pro will actually create that column for you. I've already done that, so I'm going to cancel this, and I'm going to say, okay, here's my BXW. That's all set up and ready to go. So now I'm going to take my measurements off from the 5 centimeter run. So I'll click on Analysis Tool in my IO Lab software, drag over the region, and you can see here are my values. So now I go into Logger Pro. I'll record the mu values for X, Y, and Z that are non-faded. So that is 91.199. Notice on Logger Pro that when I entered the value in for BXM, it immediately calculated out the value of the magnetic field of the wire. I subtracted off this value, 84.118, from this measured value, and there you have it. I'll do it for the other ones too, so you can see. And let's see, one more there. 8.781. Okay, so you can see here are my values for D equal 5 centimeters. These are the measured values from the Logger Pro unit. I subtract off the magnetic field, the components of the magnetic field of the Earth, which are here, and I get the wire value, the wire field for each component. Now, this last column here is the magnitude of B. I already programmed this into my spreadsheet, but I'll show you what the formula looks like. So I'll just double click on the column, select column definition, and as you can see, this is not a huge surprise to many of you who've taken the calc or algebra-based physics. This is just the magnitude of the vector field. Bxw squared plus byw squared plus bzw squared square root that. Pythagorean theorem all over again. And that calculates the magnitude of the field. You're going to use that later on in a curve fitting to actually look and see what the behavior of the field looks like as you move further and further away from the wire. So this hopefully is a good lesson for you in using Logger Pro. I think there is a comparable lesson for using Excel. So that's it.